Today we're still solving trig equations. This time we are going to use the quadratic formula. And again, an equation whose variable is expressed in terms of a trig function value is a trig equation. Now yesterday we saw two different methods to solve this equation by either factoring to the square root method. Today I'm going to show you a third way, the quadratic formula. I'm not going to go over method 1 and method 2 again right now. As a reminder, the quadratic formula, we learned it as the following. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. A is the number in front of the squared piece, b is the number in front of just the sine or the cosine, and c is the constant or the number by itself. So for this particular problem, a is equal to 4, b equals 0 because there is no sine or cos theta, and c is equal to negative 1. Instead of this being an x equals for the quadratic formula, we just say it's sine a equals negative 0 plus or minus the square root of 0 squared minus 4 times 1, negative 1, all over 2 times 4. So it's going to be 0 plus or minus the square root of, and if you type it in, you get 16 over 8. So it's really equal to 0 plus or minus 4 over 8. At this point, I will split it into two problems. Sine of a equals 0 plus 4 over 8. And sine of a equals 0 minus 4 over 8. Well, that's just a 1/2, which we did do this problem yesterday, so you can just look at your notes yesterday. You get 30 and 150 as your answers there. And then for the other one, it's negative 1/2. And again, we did this problem yesterday, so I'm not going to go over it again today. You get 210 and 330 as your answers there. So another way to complete your problems to solve these trig equations. Today we're going to practice using the quadratic formula for these problems. So for this first one, let me see for one sec here. Yeah, let's do this first one. So my a is a 3, b is negative 7, and c is negative 3. So plugging in, it's going to be sine theta equals 7 plus or minus the square root of 49 minus 4 times 3 times negative 3 all over 2 times 3. So it's going to be 7 plus or minus the square root of 85 over 6. At this point, I will separate it into two problems. One of them is sine theta equals 7 plus radical 85 over 6. And sine theta equals 7 minus radical 85 over 6. When you type this in your calculator, please type carefully. You will have to do your inverse sine. You're going to type inverse sine is going to open a parenthesis. Open another one. 7 plus radical is going to open a parenthesis, so you type 85. Close the parenthesis on the 85. Close the parenthesis one more time. And hit division sign 6, and then close it one more time. If you type it in your calculator, it's probably error, and that's okay. When you get an error, we learned earlier, that just means it's undefined. Same idea over here. You're going to do your inverse sine. Same types of parentheses as last time. You will get an answer this time. I got around negative 21.71. So, we graph negative 21.71. That's in quadrant 4. The positive side of that is 360 minus 21.71, so 338.29, or 338.3 if I'm rounding to the nearest tenth. I'm in quadrant 4. In quadrant 4, sine is negative. Sine is also negative in quadrant 3. My blue reference angles are equal at 21.7. I want the black angle, which is 180 plus 21.7, which is 201.7. When you get an undefined, it's nice because you don't have to complete the other side. You can just be done with it. Let's look at the next one. For the next one, since I have that fraction, the first thing I'm going to do is put it over 1 and cross multiply. So I'll get 3 cos squared theta plus cos theta equals 1. I'm going to set it equal to 0. So I will have 3 cos squared theta plus cos theta equals, minus 1 equals 0. I'm going to use my quadratic formula, so it's going to be cos theta equals negative 1 plus or minus the square root of 1 minus 4 times 3 times negative 1 all over 2 times 3. So cos theta equals negative 1 plus or minus the square root of 13 over 6. Separate it into two problems, one with the plus and one with the minus. Okay, type carefully here. And do your inverse cos, same parentheses as the first time I showed you. And you get theta equals 64.3. We graph it. It's in the first quadrant. In the first quadrant, cosine is positive. Cosine is also positive in the fourth quadrant. My red reference angles are equal. So the other side is going to be 360 minus 64.3, which is 295.7. Same idea for the 1 minus 1. So we take, these are negative ones. Negative 1, inverse cosine negative 1 minus radical 13 over 6. And you will get theta equals 140.1. We graph that, which is in quadrant 2. In quadrant 2, cosine is negative. Cosine is also negative in quadrant 3. So these two angles here are my reference angles, and they should be equal. That reference angle is actually equal to whatever 180 minus 140.1 is, which is 39.9. Remember, this other side that I'm doing with the spiral is 140.1, but that's not a reference angle because it's over 90 degrees. My real angle is going to be in red. It's going to be 180 plus 39.9, which is equal to 219.9. And that's it for that problem. I'm going to leave you guys with the third one, and I'm going to start the fourth one, but you guys will finish it. So the start for this one, I'm going to subtract a 2. So it'll be 3 cosecant squared theta minus 2 cosecant theta minus 2 equals 0. Then I would use the quadratic formula. Cosecant theta equals 2 plus or minus the square root of 4 minus 4 times 3 times negative 2 all over 2 times 3. So cosecant theta equals 2 plus or minus the square root of 28 over 6. Split it up into two problems. Cosecant theta equals 2 plus radical 28 over 6. And cosecant theta equals 2 minus radical 28 over 6. Since you don't have a cosecant button, what you do is you take the reciprocal. The reciprocal of cosecant is sine. The reciprocal of the fraction is just the fraction flipped. Same thing with the other one. carefully type those in and finish that one up, as well as do the third problem that I skipped.